All right. Hi, everybody. Let's go ahead and get started here. We are going to go through the homework that you guys had before, talk about the answers to number 7, which we didn't get a chance to go over, and talk a little bit about the quiz that we're going to be having today. Okay? So let's go ahead and I'm going to go ahead and try to get in the chat here, and then see if you guys have any questions and all that, and get started. All right. So, how's everybody doing? Why don't you say hi in the chat? Let me know you're there. All right. I see 5 people online, which is great. So let me just give you guys a heads up. We do have a quiz tomorrow, not a test. Honors Chemistry, they have a test. You guys have a quiz, just a little quiz. And the quiz is going to be on everything that we've done already. The quiz will not be on this new stuff we're talking about today. So when we talk about 7, 8, 9, 10, that's not going to be on the quiz, okay? That will not be on the quiz. The main thing on the quiz is going to be stuff about, okay, what's an acid, what's a base, in terms of Arrhenius acids and bases, Bronsted-Lowry acids and bases, and maybe a little bit about pH here too. So keep that in mind. That's the stuff on the quiz, not the new stuff. And maybe at the end here, we'll go over a couple practice quiz questions. All right. So I see Sarah. Hi, Sarah. How's it going? Anybody else here with me? I know there's a few of you guys. We are up to 9. Alec. Hi, Alec. How's it going? All right. And the rest of you guys, you can, if you have any questions, just shoot me the questions. And let's go ahead and go through the homework. Now, the homework, there may have been a little bit of confusion about it. You know what? I forgot to change the due date of it. So some of you guys, the best thing that you guys could have done is to just send me this, the front side, and have already submitted it. And if you did that, you're awesome. If you didn't, no big deal. Maybe there's a little bit of confusion there. But I did not expect you guys to submit the second side because we didn't talk about it yet. Okay, so you should have submitted this, and I didn't change the due date. So what I want you guys to do for tomorrow is to do the back side. And what I'm going to do is I'm just going to leave up that assignment, and so you can just submit it to the same exact place. So you've probably already submitted this, and then you can submit this for tomorrow. Okay, so that's it. So let's go ahead and talk about the front side, and then we'll talk about how do you solve the back side. And so I think we already went through really most of this stuff last time. So this should be fairly straightforward. Hopefully, guys, a lot of these questions are very, very similar. All right. And hi, Connor. How's it going? And we have Mishik. I don't know how to say your name. Hi. How's it going? All right. So little bit of review here. Remember last time I didn't actually have this in front of me, so we didn't fill in any of this stuff, but let's go ahead and do that now. So we have a pH of blank is neutral. You guys all know that. pH of 7 is neutral. Acids have a pH that is less than 7. Bases have a pH that is more than 7. You guys need to know that. That's basic. That's your very, very simple acid-base pH stuff, okay? Auto-ionization, that's a little bit more complicated. All right, now auto-ionization of water is something that we looked at last time. Auto meaning self. So it means that water is reacting with itself. So it's going to be H2O plus H2O. And you could just put a 2H2O instead, but I like to do it this way. It's going to make H3O plus OH minus. That is a reaction that water does all the time, 24/7, nonstop. It's always doing this reaction a little tiny bit. Okay, so neutral water has a little bit of acid and a little bit of base in it. It's impossible to get rid of them. It's always doing this reaction. Okay, so why does neutral water have a pH of 7? Because the H3O plus from this auto-ionization of water is 10 to the minus 7 moles per liter in neutral or pure water, okay? And when you calculate that, when you do the actual calculation, log of 10 to the negative log of 10 to the minus 7, that's going to be 7. Simple calculation. Keep in mind, this pH is not just simply a scale and we're saying, okay, 7's in the middle. That's not what's going on. It's that the pH is an actual calculation of how much H you have, right? And so pH equals negative log of the H plus. And that H plus is simply, that's going to be the acid molarity. Okay? So that's why neutral water has a pH of 7, because neutral water has a certain amount of H plus in it from this auto-ionization. All right? And let me just go ahead and write down the base pH calculation. The base pH calculation is pH equals 14 plus the log of the OH minus molarity. And that is going to be, let me see, that right there is the base molarity that you're going to just plug into the equation. Okay? So back up, answer number 4. This is one that we didn't really answer in class, but I hope that you thought about. You have a 1 mole per liter hydrochloric acid solution. Is there any OH minus in it? And a couple days ago, you may have said, well, probably not, no. But the answer is actually yes. And why is that? It seems strange that there's hydroxide even in an acid solution. So what's going on? The reason is that you can never completely get rid of the base. Okay? So there are all water solutions, all aqueous solutions have both H plus and OH minus. And so what you're doing is you just, as you increase one, you decrease the other, such that the H3O plus or H plus molarity times the OH minus molarity is always equal to 10 to the minus 14. And you can never have one of these equaling to 0. Because if one of those equal to 0, the other one would be like infinite, and you just can't have that. That's not possible. So no matter how much acid you have, you always have some amount of base. The more acidic it is, the less base you have, but it's not going to be 0. Okay? The more base you have, the less acid you're going to have, but it's never going to be 0. It's always just a balance. Okay? All right. So stop me if you guys have any questions. I know we kind of went over this last time, so I'm trying to go through it fairly quickly and just check your answers. If you're stuck, if you got anything wrong, just stop me. All right? But let's go down here. Now, we went through a whole bunch of pH calculations together, but they weren't necessarily the same ones because I didn't have my worksheet with me at the time. And so all of these, the key here is choosing the right equation. We have these two equations. The first thing you have to do is identify, is it an acid or is it a base? And the second thing is you have to put it in your calculator the right way. All right? But they're fairly straightforward as long as you can do those two things, identify acid or base, and put it in your calculator the right way. So here for HCl is an acid. How do we know? Because it's got H in front, right? And NaOH is a base because it's got OH minus there in the back. All right? And that's how we're going to identify these things. So this is going to be negative log, first one, negative log of 0.01. That gets us a pH of 2. And then you can do the same thing, negative log of 0.1. That's going to be a pH of 1. And I know that in my head simply because this is 10 times as acidic as this, which means you've decreased the pH by 1. Same thing here. A 1 mole per liter HCl is going to be a pH of 0. Right, which is 10 times more acidic than that. And then once you go to 10 molar, it's 10 times more acidic than that. It's going to be minus 1. Okay? But once we get to bases here, it's a 2 here. Once we get to bases here, now we're going to use the other equation. It's going to be 14 plus the log of that molarity, 0.1. Okay, and that's going to be 13. Now, I have a question. Let me pause there and see. Sarah's got a question. Where did you get the 10 to the minus 14 in number 4? This 10 to the minus 14 is not something you're going to need to worry about or memorize or anything like that. It's a physical number. It's a physical constant, okay? So it's a physical measured constant. Okay? And so somebody in the lab measured this number, and that's where that came from, that 10 to the minus 14. So it's not something, that's theoretical. It's actually like somebody went to the lab and they can measure this amount. And so they got that number, 10 to the minus 14. Okay? All right. But we're not going to use this equation per se. I just wanted you guys to see that you should understand that this whole thing is really a balance between H plus and OH minus. Okay, back over here, identifying KOH as a base means I'm going to use the base equation. So it's going to be 14 plus the log of 0.003, right? And this is going to be 11.448 or 477, however you want to do it. Technically, it should be 11.48 for significant figures, but we're not going to worry about those. I want you to give me, guys, when you have something that's not exact, give me plenty of digits, numbers after the decimal point so that, I know that you got the answer right. If you wrote, for example, let's say 11 for this one, I'm going to mark that wrong, okay? I need to know that you know that it's 11.48 or 11.477, okay? All right. This one coming down here is nitric acid. We have an H in front, so we're going to use the acid equation. So it's negative log of 0.00063, which gives us a pH of 3.2. Okay. Next one, lithium hydroxide. And so you have an OH minus there. So that's going to be a base. So once again, this is going to be a 14 plus the log of 7.5. All right, and that's going to be a pH that's higher than 14 or 14.875, or you can say 14.86. Either one's fine. And last of all, there's an H in front. That's perchloric acid, and so we're going to use the acid equation, negative log of 0.00069. When you get problems like this, be careful how many zeros you have, okay? So do that. That's going to give us a pH of 4.16. All right, so that's page 1, and I got a question here, and let's look at that. So where did the CO go? CO. You mean the CO here for HCl? Is that what you're talking about? And we have, I don't understand what we're doing in number 4. Number 4. So back up, you're still back up here to number 4. Now number 4 it's really just a general concept. You don't need to really look at these numbers, okay? So the general concept is just this. Anytime you have water, you're going to have both H3O plus and OH minus, okay? So you're going to have both of those in solution. No matter how much acid or base you have, you're always going to have a certain amount of the other one. As we add acid, base decreases. As you add base, the acid decreases, but you always have a certain amount of both in any water solution. Now, I guess you're talking about this CO. Where did the CO go? The CO went nowhere. The CO is right there, but the CO is doing nothing. And that's going to be the whole basis of all of our calculations. Okay? When HCl dissolves in water, it's going to react with water, and it's going to make H3O plus CO minus. Okay? And we have things, we care about that. That's our acid component. That's what HCl is doing when it goes in water. It's going to ionize. We call this process ionization, right? And the H is going to stick to the water, and we're left with Cl minus. The Cl minus we don't care about. It's there. It didn't just disappear. We just don't care about it. Why? Because it's not an acid. It's not a base. It's just doing nothing, right? So it does nothing. And so we're going to ignore it most of the time, but it's still there, okay? And so that's called, the Cl minus is called a spectator ion, okay? Spectator, and it's just sitting there watching what's going on, but it's not really doing anything. And so that's why we're going to just ignore this a lot of the time, okay? But it's still there, all right? Right, you have, and so back up here, you have HCl, not water, but it's in. So pay attention to the solution here. This is 1 mole per liter HCl. So 1 mole per liter means you have mostly water, right? 1 mole per liter means you have 1 mole. What does that mean? So 1.0 mole per liter HCl. That means you have 1 mole of HCl dissolved in 1 liter of water, right? That's what that means. Okay? And so there is water. There's going to be water in all of the solutions that we're going to be talking about. All right? It might not necessarily tell you, oh, hey, there's water there too. But yeah, when you have, anytime it says mole per liter, that's a concentration. You don't have pure HCl. Okay? And in fact, if you had pure HCl, it would be a gas, and you wouldn't be able to talk about it by itself, right? And so yes, if you had pure HCl, there would be no OH minus because it's pure HCl. But that's not what you have. You have 1 mole per liter HCl, which is a certain amount, 1 mole of HCl dissolved in 1 liter of water. So there's a whole lot of water. Okay. All right. So that's the front page. Any other questions on the front page? All right. I'm going to go through number 7 on the back page, and then I'm going to let you guys do the rest of the back page for homework, and then we're going to talk about, for the remaining time, we'll talk about the quiz and give you guys a couple practice problems for the quiz. Okay? But the practice problems we're just going to do here in class. I'm not going to give you any extra homework or anything like that. All right? So, with that said, let's just do, another question. Number 4, why is the 14 negative? The 14 is negative just because that's how much you have. Like I said, this is a physical measured constant. This is not something that you're going to derive. But let's see, not why, but what does that mean? 10 to the minus 14 means is a very, very, very small amount. Okay? So 10 to the minus 14 is a very, very small number. Okay? So when you have neutral water and you have 10 to the minus 7 mole per liter H3O plus and 10 to the minus 7 mole per liter OH minus, that's a small number. So pure water is mostly H2O. You only have a very, very, very small amount of H3O plus or OH minus in it. Okay? And that's the whole minus thing. It means that you have a very, very small amount of this or this. Okay? All right. So those numbers we're not going to really worry about. All right? I'll go over some practice quiz questions here in a little bit. Number 7 here on the back is going to be a little bit of review of molarity and a little bit of a stretch for us. But it's going to be connecting stuff that we've learned before together, and it's going to be important. All right? But we're not going to have this on the quiz. All right, so this is going to be homework. And you know what I'm going to do? I don't think we have class on Thursday, and maybe we do, because I don't even know. Maybe this is a D week. Who knows what week it is? But I'm just going to make this homework, the rest of this homework, I'm going to make it due Thursday for you guys. Okay, so for tomorrow, you can just focus on practicing and preparing for the quiz. Okay, and if you want to do this homework right away, that's great. You're awesome. But I'm going to make this homework not due till Thursday as you guys prepare for the quiz, which is tomorrow. All right. That said, let's go ahead and do number 7. All right. if we dissolve 10 grams of sodium hydroxide in 250 milliliters of water, so an aqueous solution that's talking about, that's water, right? What's the pH? So now, remember for pH, the whole thing for base, so this is, we know first of all, this is a base. So the equation for the pH is going to be pH equals 14 plus the log of this OH minus molarity. And we know, okay, this means the molarity of the base that you have, and you don't know the molarity of the base. So your goal in this is, well, you need to calculate the molarity of the base. And we've done that before. We've calculated molarities. Molarity is the number of moles over the volume. And so this is going to be moles of your base, and this is going to be your volume of the solution in liters. Okay, so there's a lot of parts to this problem that we need to be able to do. All right, so let's start from the top. We need to calculate moles in order to calculate the molarity, in order to calculate the pH. Okay, so let's just talk. Let me even just write the steps down here somewhere. Okay, so let me write them, if you don't mind, down on this other problem. Okay, so first we're going to calculate moles of your acid or base, whatever you have in the problem. All right, and then you're going to use the equation M equals N over V to calculate the molarity. That's molarity. And in the process, most of the time, this volume you're going to need to convert to liters. Okay? You might have it in milliliters. And then lastly, step 3, we're going to calculate the pH from one of those two equations. pH equals negative log of H plus, or for a base, pH equals 14 plus the log of the OH minus molarity. Okay, so those are the steps that we're thinking. So let's go ahead and do number 7 and do step 1. That is, we need to calculate the number of moles we have. And now we notice there's actually kind of a step 0, a step before step 1, and that is, in order to calculate the number of moles of sodium hydroxide, we're going to need to know the molar mass of sodium hydroxide. And so we can just add a little step 0 in there, and that's going to be for the molar mass. All right, so I know that's going to be kind of a lot of steps here, but this is all stuff we've all done this stuff before, okay? So it's just a little bit of, kind of bringing everything together. So the molar mass of sodium hydroxide, let's do that. And that's going to be 1 sodium, 1 oxygen, and 1 hydrogen, right? So let me do that. In your calculators, it's going to be 22.99 for the sodium, right? Plus an oxygen, which is 15.999, plus we have 1 hydrogen, 1.0079. So that is the molar mass of NaOH. Right? And you can round it off if you want a little bit, but don't round it off too much. So we have, this is going to be 39.997 grams per mole. Okay? So step 1 is to take this 10 grams of NaOH and convert it into moles. So we have 1 mole. What we're solving for goes in the top, 39.997 grams. What you're starting with goes in the bottom. So if we start with grams, the grams goes in the bottom. We're solving for moles, so moles goes in the top. And so that's going to be, in your calculators, 10 divided by this number, or I'm just going to use what's already in my calculator, and I'm going to say 10 divided by my previous answer. That gets me a number of 0.25. 0.25, and we have 0.25 moles of NaOH. All right, step 2, calculate the molarity. The molarity equals the moles divided by the volume, so that's going to be 0.25 moles on the top. What about the volume? Here, the volume says 250 milliliters, right? 250 milliliters. Oops, let me bring that down a little bit. 250 milliliters, but that 250 milliliters is in milliliters, and we need to make sure that that is in liters. And so to convert between milliliters and liters, we remember there's 1,000 milliliters in 1 liter. So we're going to take that decimal point and move it 1, 2, 3 spots to the left. And so that is 0.25 liters. If you don't trust me, you can go ahead and do it in your calculator. That's going to be 250 divided by 1,000, right? To convert from milliliters to liters, you divide by 1,000, so that's going to be 0.25 liters. And now we get to fairly easy math. This is nice. 0.25 divided by 0.25, any number divided by itself, well, that's going to be 1. So that's kind of convenient. 1 mole per liter. All right, step 2 is done. Now, step 3, we're going to calculate the pH. To calculate the pH, we need to use one of these equations. Well, which equation are we going to use? Because this is a base, it's sodium hydroxide, we are going to use the base equation, the equation with OH minus in it. So our pH equals 14 plus the log of our molarity, our base molarity, the log of 1, okay? And you can go ahead and plug that in your calculators. That's going to be 14 plus the log of 1, and that's going to be 14 because the log of 1 is 0. 14 plus 0 is 14. And that's our final answer. Okay? Final answer, 14. All right, let me pause there and just ask you guys have any questions on number 7? Numbers 8, 9, and 10 are done the same way, except keep in mind numbers 8 and 9 are acids, and number 10 is a different base. So you guys need to deal with those differences, whether it's an acid or a base. Make sure you're able to do that. But this, 8, 9, and 10, will not be on the quiz tomorrow. So if you want, you may turn this homework in on Thursday, and it won't be late, all right? Just prepare for the quiz. So I'd like to take the remaining few minutes that we have, or actually we have 12 minutes remaining, take the remaining time that we have to discuss just some practice problems, what's going to be on the quiz, okay? If you guys would like. All right, are the moles of base and volume always the same? Same as what? No, it's going to depend on what you have. I'm not sure what your question is. But let me first answer Anna's question. But it's the same steps through. Yes. So these steps are always going to be the same. It's just what's going to differ is going to be the numbers. So if you have a different chemical, that's going to be a different molar mass and a different amount of acid, that's going to be a different number of moles, right? So here you have 1 gram, and here you have 0.33 grams, right? Which means you're going to have more acid in this case, so we're going to expect a lower pH in number 8 than number 9, all right? So that's going to affect things. So we're going to change the numbers in each of these problems, but the steps are always the same. Calculate the molar mass, calculate the number of moles, calculate the molarity, and finally plug in the molarity to the pH equation. So Connor says, if not, I understand how you got 0.25 on the top, but how did you get 0.25 for volume? Good question. How do we get 0.25 for volume? Yeah, so they're not always the same. So the volume is going to be the milliliters. We're going to take the decimal point and move it 3 spots to the left. So let me just go through number 8. The volume here is not going to be 200 because that's in milliliters. We have to convert it to liters. So the volume in this case is going to be 0.2 liters, okay? Just like down here for number 9, the volume is going to be 750 divided by 1,000, or 0.75 liters, okay? It just so turned out that we got lucky on number 7 that these two are the same. But most of the time, they're not going to be the same. They're going to be different. Okay? All right. So I'm going to leave that for homework for Thursday. All right? And we're going to go ahead and just do some sample problems then of what you might see on the quiz. Okay? So I'm just going to make some stuff up as we go and think about, what kinds of stuff are going to be on the quiz. So on the quiz, let's go this direction. You might have to, let's say, identify the, actually, let me do it this way. Which of the following is an acid, base, or neither? So we're going to identify these as acid, base, or neither based on the Arrhenius definition. Okay, and so let me give you guys some things. So let's just do H. Okay, so we have a few different chemicals here, and we want to identify them. You're going to have a question like this in the test. Or no, not test, quiz. Sorry about that. And you're going to need to identify each of these as acid, base, or neither. All right, and the simple thing that we're going to do for Arrhenius, when you have a single chemical and for Arrhenius definition, you're going to just look at the front. If the front has an H, it's going to be an acid. Okay? If the front has an H, it's going to be an acid. And you're thinking, oh, okay, H2O, that's going to be an acid. But actually, this is the one exception to that. Water. When you see water, water is neither an acid nor a base according to Arrhenius, right? Because water is just neutral, right? So it's going to be neither an acid nor a base. And so you just be careful about that, all right? I probably will throw that on there for you. And so make sure you know, okay, water is not an acid or a base according to Arrhenius. Obviously, Bronsted-Lowry would call water can be either an acid or a base, right? But for Arrhenius, water is neither an acid nor a base. It's neutral. So back up here, KOH, when we see that OH there, well, what are we looking for? Right? In all of these, you're looking for an OH in the back or an H in the front. When you have an OH in the back, this means it's a base. Okay? Lithium hydroxide, once again, we have OH in back, so that's going to be a base. And then HNO, we have an H in front, so that's going to be an acid. All right? If you have something else, let's suppose you have something else like, I don't know, we have Li2SO4. When you have something like that, it doesn't have an OH and it doesn't have an H, you're just going to say, well, that's going to be neither. Okay? That is the Arrhenius definition, just a simple definition of looking at something as an acid or base, whether it has an H or an OH minus. Okay? All right. Now, we also have to be able to identify acids and bases according to the Bronsted-Lowry definition, which means, and I'm not going to have you guys write out definitions in the test or quiz. Yeah, we're not going to do that. We're going to do something like this, okay? So let's look at Bronsted-Lowry acid-base reaction. And so if we have, let's say, let's do it this way. H2SO4 plus NH3 goes to NH4 plus SO4 2 minus, which means we have 2 of these and 2 of these. So let's suppose I give you a reaction like this, okay? And you need to identify what is the acid, what is the base, what's the conjugate acid, what's the conjugate base. So that's going to be something that you're also going to have to do. And so the way you're going to do it is you're going to look at these chemicals and say, okay, which one is giving up an H+, which one is losing an H+ in the process. And so you're going to follow along the back part of this. So H2SO4, we follow along the SO4, find it over here. So H2SO4 is turning into SO4 2-. In that process, it has lost 2 H's, which means the thing that loses H's is the acid, and the thing it turns into is going to be the conjugate base. Okay? Which means the other thing must be the base, but let's make sure. Here we have NH3, here we have NH4+. The NH3 has gained an H+. And so because the thing has gained an H+, whatever it gains an H+ is going to be your base, and the thing it turns into is the conjugate acid. Okay? Let's look at another one, a little bit of a trickier one. All right, so let's see. You have H2SO4 plus let's do HBr. And what's going to happen is you're going to get H3SO4 plus Br minus. Okay. This one's a little bit trickier. Why is it trickier? Because both of these are Arrhenius acids. Both of these look like acids. And so now you can't just say, oh, okay, H in front, that's an acid. And then you'd be like, H in front, that's an acid. Where's your base? This is a Bronsted-Lowry type of acid-base reaction, so you have to pay attention to what's on the other side. What we're going to do once again is we're going to follow where this chemical goes. So you have SO4 and you have SO4. So this is turning into this. And when it does that, notice that the H2SO4 turns into H3SO4 plus. So that thing is actually gaining an H, right? Going from H2 to H3. And so it's gaining an H, which means that this must actually be our base. And this is going to be our conjugate acid, okay? And then this thing is going from HBr to Br minus, which means it has lost an H, which means this is going to be our acid, and this is going to be our conjugate base. Okay, so that means looking at all these chemicals here, which of those chemicals is acting in a as an amphoteric thing? Okay, now there's actually more than one thing that can be amphoteric in this page, but one of them is being demonstrated to be amphoteric. And which one is it? What do you guys think? Which chemical is being demonstrated in these two reactions to be amphoteric? In order to do that, you need to know what amphoteric means. Amphoteric means it can act as an acid or a base. Amphoteric is acid or base. And so we can identify, well, which one's amphoteric, and we say, okay, here H2SO4 is acting as a base, here H2SO4 is acting as an acid, and that means H2SO4 is amphoteric. Okay, because it can act as an acid or a base. All right. So, question. So lose H is an acid, gain H is a base. That's exactly right. That's the definition of a Bronsted-Lowry acid base. The Bronsted-Lowry acid gives up or loses an H. The Bronsted-Lowry base accepts or receives that H. Okay? All right, let me see. What else will be on your quiz? Monoprotic, diprotic, triprotic, right? You guys should know those definitions. And so let's say I have another question. Identify a diprotic acid here. All right, and so, okay, we say, all right, this one's diprotic because there's two H's. H2SO4, that is diprotic, okay? And so you should be able to identify something as diprotic or triprotic or something like that. Or it could say, you know, tell me a triprotic acid, all right? Triprotic acid. That would be something like H3PO4, okay? And then polyprotic is going to be both of these are polyprotic. Polyprotic just means that they have more than one H. All right. Let me see. I think that's just about it. The only other thing that's going to be on your quiz will be stuff from like this, okay? So maybe I think there'll be one of these pH calculations, all right? Now, the quiz itself is going to be open notes. I'm going to give you guys the entire period to work on it. It's not going to be super long. And so once you're done with the quiz, maybe you can take the time to finish up the homework here, okay? So that's about it. Any last minute questions? I do want to remind you guys, you may not talk to each other about the quiz. You may not ask for help or give help to anybody else. So the quiz is your own work, but it is open notes. You can use any of the notes that you guys have. You can use your homeworks. You can use, you know, the book, whatever you guys want. That's fine. It's open notes. But you may not discuss it or talk to another person about it. Any questions before we split? All right. So if that's it, I'm just going to head out